welcome to this video lesson. Here we will be looking at the idea of density, and we'll do some practice questions that involve density. The idea of density has to do with how much mass is concentrated into a certain amount of volume. And the equation for it is that density, which we show using this curly P letter, which is called rho, is equal to the mass over volume, meaning that if you have more mass concentrated into a certain volume, your object is a little bit more denser. When we're looking at this in terms of the particle point of view, then if we had the same volume and we had the same substance, meaning that all of their particles had approximately the same mass, that would mean that if one of these had 4 particles in them and the other one had around 8 particles in them, then the object which has 8 particles in this set of volume has a larger mass, twice as much as this, because each particle has about the same mass. This has twice as much, meaning that the mass, let's say this is object A, this is object B, so the mass of B is larger than mass of A, and if they had, and we know that their volume is the same, we can see that in the diagram, they're approximately the same volume. That would mean that the numerator in terms of this equation is larger, or conceptually B is more massive, or has more particles of same mass within the same unit volume, and therefore it's denser. So in this particular case, the density of B would be larger than the density of A. And again, this curly letter is usually what we use in terms of writing volume, and this is the density. The letter is called rho. This is our mass, and this is our volume. Now we can also look at this in terms of what happens if we had different volumes but the same mass, and the idea doesn't really change. So let me just use a different color here to represent this. Let's say in the smaller box we have 4 different particles, and in the larger part we also have 4 particles. All of these particles have approximately the same mass because they're the same substance, and here mass of A is going to equal to mass of B. However, the volume of A is much smaller than volume of B. And which one is denser? Well, you can see that the particles here are much more dense. They're much more closer to each other compared to this, meaning that the density of A is larger than the density of B. And we can go back and use the equation, and we would also get the same idea. Here the volume is in the denominator, meaning as the volume increases, the density actually decreases, and that's exactly what's happening. You can see as the volume is increasing, the spacing between all of these particles gets less, and the density of it actually gets lower, meaning that the same amount of mass is concentrated in a larger volume here compared to this one, where the same amount of mass is concentrated into a smaller section. So with density, if the density is large, it means that usually particles are packed really close to each other in a certain volume, as compared to when density is smaller, it means that the particles are packed much further apart from each other, or there's more spacing between those particles within the same volume when we are making the comparison. Now, for this equation, we want to do a little bit of unit analysis, and mass usually is measured in units of kilograms or the units of grams, so I'm going to include those two here. And volume is often measured in units of meters cubed, or we can also measure it in centimeters cubed. And these two are most often used to measure the volumes of solid because we can take the measurements using a ruler, for example, and use those to find the volume. Or if we are using a liquid or a gas or a fluid, basically we will use the units of liters or units of milliliters. Now, the way we can convert between these are defined. We can 1 meters cubed is actually equivalent to 1,000 liters, and 1 centimeters cubed is equivalent to 1 milliliter. And this is the one we're going to use most often in chemistry. So I'm going to highlight this one as the one that we use more often. And therefore, if we were to look at the unit for density, density again is equal to m over v, where the unit of mass is usually in kilograms, and the unit of volume is often written in meters cubed. And this is one very common way of expressing the unit. Another very common way of doing it is just grams per centimeters cubed. And another common way of expressing it is grams per milliliters. There are other ones as well that are used, but these are pretty common, especially the first two. And another way of writing these units, by the way, just so that you know, this is in North America, we often use this method, but in Europe, a lot of times we use something like this, where we have the kilogram, but since we have meters cubed in the denominator, mathematically we can bring that up to the numerator and it gets a negative exponent. Meters is the only thing that we're bringing on. We can also, for the other one, is gram centimeters to the negative 3. And for the other one, it's gram. Gram doesn't change. It's on the numerator, but milliliter comes to the exponent as negative 1. So these are another method of showing the exact same units. Now we can also convert from one unit to another, and we'll talk a little bit more about that later in this video. Now, when it comes to chemistry, there's certain values and conversions that you really need to know by heart. And instead of using the word memorization, I'm going to say that you really need to have a deep learning of this. And you're going to be using this a lot if you want to become a chemist or a scientist. Even in physics, we use similar values. I believe in chemistry, when you're doing some of the lab work, you'll probably be using very similar conversions. These are only some of the ones that you need to know, but there's more of them, but these are the ones we'll use today. The first conversion that you need to know is that 1 meter is same as 100 centimeter. So 1 meter is equal to 100 centimeters. 1 kilogram, you need to know that that is equal to 1,000 grams. You also need to know that 1 milliliter is going to be equivalent in terms of volume to 1 centimeters cubed. You may also use that 1 liter is equal to 1,000 milliliters, and these are all defined. So we have defined 1 meter to equal to 100 centimeters, 1 kilogram to be 1,000 grams, 1 milliliter to be 1 centimeters cubed, and 1 liter to be 1,000 milliliters. So these value, I want you folks to really have know it by heart. How would I use this in a basic conversion? Well, let's see. Let's say I have 250 kilograms and I want to convert it into grams. The way I do that, and obviously you can't change kilograms into centimeters because this is length and this is mass. So you need to be able to convert between the similar units. Here I have 250 kilograms. I want to convert it into grams. And the way I do that is I write the 250 kilograms and I multiply it, and I need one conversion. I need to change the kilograms into grams. Well, since in terms of the unit analysis, kilogram is on the numerator, in order to cancel it out into 1, I would have to write it in the denominator. Note that when you divide something by itself, it equals to 1. So they cancel out to 1, and that's exactly what we want. We want to cancel them in order to get them to 1. And 250 times 1 just gives you 250. So it's nice. Basically, we have canceled out the kilogram. But we're not just trying to cancel them, we're trying to convert it into grams. So because I want the kilogram to change into gram, I'm going to write that in the numerator. Now, based on what I need to deeply understand is that 1 kilogram is equal to 1,000 grams. Now, the kilograms cancel out to 1, and I'm left with grams. I'm left with exactly what I need. So if I remove these, and in terms of units, I'm only left with this, this is same as writing 250 times 1. Notice that the kilogram has canceled to 1. I don't have to write 1 whenever I'm multiplying things by it. Multiply it by 1,000 grams. And I'm dividing so no denominator here, no denominator here, so that means the denominator is 1. Denominator here is 1 also, so you can divide this by 1, but you don't, everything divided by 1 is itself, so I don't have to write that. And I'm finally left with 250,000 grams, and that is my conversion. So that's converting something from kilogram into grams. Let's do another conversion so you can see. Let's do 450 centimeters cubed into, let's change it to meters cubed. So a little bit more challenging, but let's try it out. I'm going to write this as 450 centimeters cubed, and I'm going to do a multiplication. And I'll show you this using two different methods to kind of get an idea about the simpler method and the longer method. I'm trying to get rid of a centimeter here, and in order to get rid of centimeters cubed, really, in order to get rid of it, I need to write it in the denominator here. So I'm going to do that. And when I go and look at a centimeter, I can somehow convert centimeters cubed to milliliter, but that's not what I'm trying to do. I'm trying to convert centimeters into meters. So I'm going to write a meter here, and I know that 1 meter is equivalent to 100 centimeters. Now I've done that once, and this is centimeters cubed. Another way of writing this, I'm actually going to, for a second, just erase this part. And instead of centimeters cubed, I'm going to write it as centimeters times centimeters times centimeters. And I'm going to write that 1 meter is equal to 100 centimeters. So this is cubic centimeters, meaning centimeters multiplied by itself 3 times. And I now just, by doing this, I get rid of one of the centimeters. These ones will cancel out to 1. But I have 2 left. So I need to do this conversion twice more. So I'll do it 1 more and 1 more. I'm going to get rid of another centimeter by writing it here, another one here. So these are, and sorry, I'm going to change them to meters. 1 meter is 100 centimeters. 1 meter is 100 centimeters. And by doing this, the centimeters will cancel out. And I'm left with meters multiplied by meters multiplied by meters, which is going to be a cubic meter, or meters cubed. And to finally write this, it becomes 450. Note that all of this have changed to 1, because when we divide centimeters by centimeters, we just get 1. I don't have to write the multiplication. 450 times 1 times 1 times 1 is still 450, times 1 is still 450, times 1 is still 450, times 1 is still 450. So in the numerator, I have 450, and on the denominator, I have nothing here, so it's a 1, times 100, times 100, times 100, times 1, 1, 1. Multiplying by 1 is just the value itself. So in the denominator, I have 100 times 100 times 100. And just to highlight things, just to show you uh, so that you can see it a little bit easier, that's the 100. The 450 is this value over here. And I've now gotten rid of all of these. These are all removed. And what I'm left with is meters, 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 which make a cubic meter like this. And I'm just going to highlight this as meters cubed. And that's what I get. So in order to write my final answer here, I'm going to write it as 450 divided by a million, because 100 times 100 times 100 in the denominator will be a million. And I get 0.0000450, or I'll just leave it as 0.0045 cubic meters, and that's my final conversion. Now, there's an alternative way of doing this as well, so I'm going to write it on the side here. And it's exactly the same idea. You're still converting 450 centimeters cubed to meters cubed. So I'm going to write it as 450 centimeters cubed. This time I'm going to keep it as cubed, multiplied by. And I'm trying to get rid of the centimeter and convert it into meter. So I'll write it like this. And I know that 1 meter is equal to 100 centimeters. I'll write it like this. But now, instead of writing it 3 times, I have an understanding of what's happening. When I multiply things by 3 times, 1 is multiplied by itself 3 times, so it's cubed. Meters is multiplied by itself, it's cubed. 100 is multiplied by itself, so it's cubed. And centimeter is multiplied by itself 3 times, so it's cubed. And isn't this much simpler? Basically, you get rid of the centimeters like this, and you're left with meters cubed for your final value. And you can just write it as 450 times, in the numerator you have 1 cubed or just 1. You don't even have to write this one. And on the denominator you have 100 cubed. You can write it as 100 cubed, or you can write it as a million. You're left with meters cubed here, and your final answer will be 0.00045 meters cubed. When you put this on your calculator, or if your math skills is strong enough and you know that you would have to move the decimal point at 6 to the left because you're dividing by 10 to the 6. And this is how you would do unit conversions when it comes to these types of questions. All right, let's go through a few examples. The first one says to calculate the mass of a 2-meter cube of oak. And here we don't have the density value of oak, so I'm going to put that in here. And I'm going to write it right here. This is approximately 600 kilograms per meter. So I'm going to write it as 600 kilogram per meters cubed. Sorry, that's what I meant to say. And we want to use that idea, and we need it for both questions. That's why I put it in the corner there. And the value that is given to us here, 2 meters cubed, as soon as we look at the unit, we should be able to identify that either as mass or as volume. And since it's meters cubed, and it makes sense because it's a solid, it's meters cubed and not liters or milliliters, this is going to be our volume. So I'm going to write that our volume is 2 meters cubed. Our density again is given as 600 kilograms meters to the -3 or kilograms per meters cubed. You can write it like that as well. And mass here is the question mark. We're trying to figure out what that mass value is. Now, how do we do this? Well, we're going to start off by writing the equation. Density is equal to mass over volume. The information that is given to us, or that are given to us in the question, are the density and the volume, and we're trying to find mass, so we need to rearrange for it. In order to do this, we have to multiply both sides of the equation by the volume in order to get rid of it here. And I'm going to put a curly bracket here just to say what I did. I multiplied both sides by v. And when I do that, the left-hand side becomes rho times v. And the right-hand side, I'll just write it out in an extra step, and I'm going to skip this step in future. The volumes cancel out, so I'm multiplying both sides by volume in order to isolate for the mass. Once isolated, mass becomes rho times volume, and now we can just start putting the numbers in, and I'm going to try to write it a little bit bigger in case you're looking at this in a smaller screen. So the density is 600 kilograms per meters cubed, and I'm going to write it out like this for a good reason that you will see a little bit later, multiplied by the volume value, which is 2, and the unit is meters cubed. And I'm going to leave it like this. In this situation, if you look at the different units, we see that this one is in kilogram, this meters cubed, this one is in meters cubed. So just looking at the units and not the numbers, on top we have kilogram, denominator is meters cubed. Here numerator is meters cubed, nothing in the denominator. You can also write that as over 1 if you wanted to. It's completely up to you, but you don't need to. And here I have meters cubed in the numerator and meters cubed in the denominator. Whenever you have those, these two are going to cancel out to 1 because meters cubed divided by meters cubed is just dividing the same thing by itself, which ends up being 1. And what you're left with, I'm going to highlight everything that's canceled out in red. And the only thing that we're left with in terms of our unit is kilograms, which is the mass, which is exactly what we need. And the 600 gets multiplied by 2, and therefore mass is going to equal to 1200 kilograms. That's what I'm left with. Basically, on the numerators, I have 602 being multiplied by each other to give me 1200. And my units that I'm left with is kilograms because these canceled out. And it's not asking me to leave my final answer in a certain unit, so I can just leave it as kilogram, and that's fine. Whenever you're doing any type of science questions, you always have to look at the number of significant digits as well. And we're not going to go over how to count the number of significant digits. You can find a video on that a little bit later, but we will go over the concept of how to apply it. So here the volume has 2 significant digits. So I'm going to use another color here. I'll use pink. And I have 2 significant digits or significant figures. So I'll write it as SF for significant figures for my volume. But my density is only given to me in 1 significant digit or 1 significant figure. So I'll write it as 1. Notice that in this value over here, I have 2 significant digits, meaning that this number was either rounded down from 2.04 or rounded up from 1.95. Those are the 2 extreme values, and we can also look at 2.04999999. But that's kind of the concept. So the 2 significant digits tells us that we're kind of sure that we know the value up to 2.0, which is good. In this one, the value is only given to us in 1 significant figure, so the 600 could have been 550 rounded up, or it could have been 649 rounded down. So the uncertainty here is a lot more on this value as compared to this one. Our final value here is in two significant figures at the moment, and this is kind of saying we're kind of sure about the value up to two significant figure, but we're really not, because this value over here is causing an issue. We are only sure about this up to one significant figure. And if this was 550, the final value would be a lot different. And if this was, let's say, rounded down from 649, this value would have been quite different. So when we're multiplying or dividing, we always write our final answer in the least number of significant figures. So in this case, the least number of significant figures between the two values that we used initially is just 1, meaning my final answer needs to be rounded down to that many number of significant figures. In order to write this properly, instead of the equal sign, I'm going to say mass is approximately equal to 1,000 kilogram. Now, the 1,000 is rounded down, and the most significant digit is always the non-zero value that is to the left. And the first non-zero value that I have here is this one over here, and any zeros after that in this particular case, because there's no decimals and anything after that is are insignificant. So my final answer here is expressed in one significant digit, and I am going to highlight my answer, and I can also just box it. Sometimes I ask my students to box the answer. Let's do the next question. Let's calculate the mass for 27 centimeters cube of oak. And notice that this time our density is in a different unit compared to the volume that we have. I'm going to write the information that I have. Volume is equal to 27 centimeters cubed, and the density is equal to 600 kilograms per meters cubed. So I'm going to write it like this. And we're trying to find mass similar to last time. So I'm not going to go through as many steps. Rho is equal to mass over volume, and mass is rearranged to give us rho times V. And now I'm going to go ahead and write everything down. So up to the second step, it goes much quicker. Now I'm going to do the exact same thing. 600. My unit is kilograms per meters cubed. Multiply that by 27 centimeters cubed. And that's all I have so far. So let's see what I will get if I were to do a unit analysis, just looking at the units. I would have kilogram over meters cubed multiplied by centimeters cubed. Note that centimeter cubed and meter cubed are different, so I can't just multiply these, and because then I will get kilogram centimeters cubed over meters cubed, and I don't want that. My final answer is mass, and the mass does not require me to write any information about the volume, and therefore I need to find a way to remove the centimeter cube and the meter cube. How do I go about doing that? Well, this is what I have to do. I need to make a conversion, and within this conversion, I need to get rid of these two. Let's see if I can do it in one conversion, or if I need to do multiple ones. I need to get rid of centimeters cubed, and in order to, right now it's in the numerator, and in order to get rid of it, I would have to write it in the denominator, because that would mean that I would divide it. For now, I'm just going to write centimeters. We'll take care of the cube in a second. The meters here is written in the denominator, and in order to remove that, I would have to write it in the numerator. Now, I would only do that if I can find a relationship between meters and centimeters. Otherwise, I will need multiple more, or a number of conversions, a few more that can actually do that. But at the moment, meter and centimeters are related. And at the moment, it's written in the denominator, and to remove it, I will write it in the numerator. I know the relationship between a meter and a centimeter. 1 meter is equal to 100 centimeter. And these are some of the conversions that you need to know. So, in order to make the conversion, because I know that this is meters cubed and this is centimeters cubed, I am going to cube everything. So I will cube the 1, the meters, the centimeters, and the 100. This is same as writing the meter 3 times, so doing a conversion of saying 1 times 1 meter times 1 meter times 1 meter, and this would be 100 centimeters times 100 centimeters times 100 centimeters, is just a much simpler way of doing it. Now that I have this, let's see if this fixes my problem. I have meters cubed in the denominator, meters cubed in the numerator. Those will cancel out to 1. And that's what I want. Centimeters cubed, here I have it in the numerator, and here I have it in the denominator. They now cancel out to 1. And I did it on purpose. I did it on purpose in order to remove them. Now I'm just going to highlight what's removed so it's a little bit easier to see everything. And in terms of unit, the only thing I'm left with is the kilogram. And that's exactly what I want. So I've already did my conversion. My conversion is ready to go. Now, in order to do the calculation, I'm going to write it as 600. The kilogram stays, but I'm going to write it at the very end. On the numerator, here, this is a numerator, 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 and I don't have a denominator, meaning that it's just 1. It's just 1. It's 100 cubed. So this is 600 times 27 divided by 100 cubed. And I can write it as 100 cubed, or if my math is strong enough, I can write 100 with, basically, sorry, 1 with 6 zeros, which is a million. And the unit here is kilograms. Now I just put this in my calculator. I have the numerator as 600 times 27 divided by a million, and I should get a value of 0.0162 kilograms. Is that my final answer? Well, it kind of is, but I need to worry about my significant figures. My volume is given to me in 2 significant figures, or digits. The 600 is given to me in 1 significant figure. So therefore, my final answer could be the least number of significant figures from all the information that was provided to me initially. And comparing 2 and 1, the least value is 1. So my final answer can only be good to 1 significant figure. The most significant figure is the first non-zero from the left, and that's the 1. And here the 1 is significant. Everything else I need to start rounding to 1 significant figure. The number after the 1 is a 6, meaning I'm going to remove that and change this 1 to a 2. And therefore my answer is approximately 0.02 kilograms. And I'm going to box my answer, and I'm going to highlight it as well. In our next example, we have a mass of a liquid which is 400 grams and the volume is 850 milliliters, and we're asked to calculate the density. This one might be easier than the rest of them, so rho is equal to mass over volume. So this is going to equal to the mass here, which is 400 grams, and the volume, which is 850 milliliters, and I can just leave it in those units. And when I do this, I will get 0.470588, and the number continues, so I'm going to write it with 3 dots. And the unit that I get from this is grams per milliliter. Basically, I have grams per milliliter just as a fraction, just like this. And that's it. I can leave my final answer in this unit. It's a common unit used. And the only other thing that I need to worry about is the number of significant digits. I can see that here, the first value that I'm given, 400 grams, I'm not sure. Maybe it was maybe it was rounded up from 350. Maybe it was 449. So I'm very uncertain about this value. Only 1 significant figure. This one has 2 significant figures, so I'm a little bit more certain about it, but I always have to go with the least certain, which is the 1 significant figure. And my final answer is only as good as the worst or the most uncertain value here, which is 1 significant figure. So I have to round this to 1 significant figure. I look for my first non-zero value from the left, and that's 4. That's my most significant digit. My next value is a 7, which is larger than 5 or equal or larger than 5. And therefore, I will round my final answer as 0.5. And that's now one significant digit, gram per milliliter. I can, and this is my final answer, by the way, so I'll box it like this, meaning that that's the final one. But some uh, times you would see the unit written differently, so you might see the final answer written as 0.5 grams per milliliters. Sometimes you may see it as 0.5 grams milliliters to the -1. And sometimes you may see milliliters written with a lowercase l, which is another common way that people usually write it. So keep in mind that these are all the same and all of these answers should be acceptable. Just make sure that you look at the significant figures. Now, this final example, we have a cylinder of radius 3 centimeters and height of 10 centimeters. And this cylinder has a mass of 250 grams, and we need to determine its density. We can definitely do this. Let's start off by writing the information that we have. So the radius is 3 centimeters, and the height is 10 centimeters. Mass here is equal to 250 grams, and we're looking to find the density, which is equal to mass over volume. Well, we have the mass, it's 250 grams. We don't have the volume, but we do know the shape. And the volume of a cylinder is going to equal to pi multiplied by r squared multiplied by h. So I'll just write it out. Pi, the r value here is 3 centimeters. I have to cube it, so I'm going to cube both the centimeters and the 3. And the height as well, I have to multiply it by the height, which is 10, and I'll write it as centimeters. You can write in 3. You don't have to write the proper number of significant digits in your calculations in every single step. So the final value here will be will be exactly 3 times 3, which is 9 times 10, where it's 90 pi centimeters cubed, and I got that by 3 squared is 9 times 10 is 90 times pi times centimeters squared, and centimeter, when they multiply together, is going to be a cubic centimeter. Now, in this step of the solution, you can keep your answers in terms of pi, or you can multiply by 3.14 in this step. It's completely up to you. It doesn't make a huge difference. Let's move on to the next step, which is plugging it into the original equation. Note that we don't need to rearrange anything. We got the mass and the volume here. So the mass is going to equal to 250 grams. So I'll write it just like that. And the volume is 90 pi. I'll leave it as pi because in your calculator you have the pi button, and I would prefer that you use that. And you get centimeters or cubic centimeters here. And now you can go ahead and put this in your calculator. Make sure when you do that you put this in brackets, because sometimes students do 250 divided by 90 pi, and then what the calculator will do is it will use BEDMAS and think that is 250 divided by 90 times pi. So the calculator sometimes, if you don't put the bracket, might see this as 250 divided by 90 times pi. So you would have to put this, in order to fix it, you would have to write it as 250 in your calculator divided by 90 pi, or 90 times pi. So let's do it. When I put this in my calculator, I will end up getting 0.88419. And the number keeps continuing, so I'll just use 3 dots to kind of show me. And in terms of units, we can see that the units is grams per centimeters cubed, so I can just write it as grams per centimeters cubed, just like this, or cubic centimeters. Now, I have to go back and look at the number of significant digits. So I have 2 significant digits here in my original question. I have 3 significant figures or digits here, and I have 2 significant digits here. And I will have to use the least when it comes to my final value. My final value is the first non-zero value from the left is the 8. This is the most significant, the second significant, and the third one is the one that I have to kind of round or get rid of. And I have a 4 here, which is less than 5, so I don't have to round the 8 up here. And my final answer ends up being approximately 0.88 grams per cubic meter. And I can write it like this. I can write it in any other form that I have shown you, but this is the final answer that we need. Just as a note, the other concept that I need you folks to know, or just another symbol, is that the approximation sign can be shown using either this or often this is the one that's used. Sometimes you can also write an equal with a dot on top, so both of these kind of show an approximation. And by writing it this way, it also gives us an idea, or gives whoever is looking at your work to see that you're a good scientist. You've recognized that you have to go with the least number of significant digits when you're multiplying or dividing, and that you've taken care of that, and you know that even though the answer the exact answer would be very, very large, but we don't know if this was 3.0000 and this was 10.0000. We don't know our initial values to that many significant digits. So we're pretty uncertain about the 3.0. Was it 3.04 or was it 2.96? We're not sure. If we had more significant digits, then we would be more certain about our final answer and we would include more digits there. But that's as far as we know for this. Now, just before I finish the video, just a very, very, very quick example of how we would change this to kilogram per meter or cubic meter, because I know that some students might be struggling with that. So if I'm changing the units 0.88, and I'll go over this one quicker than what I usually do, and I want to change the grams into kilograms. So I'm going to write grams on the denominator and kilograms on top, and that will allow me to get rid of the grams, just like this. And I know that in 1 kilogram I have 1,000 grams. And you can do this also. Try it out and try the next part and then check your answer. And the next thing I need to change is I need to change the meters or centimeters to meters. And to get rid of the centimeters from the denominator, I would have to write it on top. And I'm trying to change it into meters in the denominator. Remember that this is same as kilograms per cubic meter. And 1 meter is 100 centimeters. And in order to get it cubed, I have to cube everything. It's multiplying by itself 3 times. And this is what I have now. And this is going to cancel out the centimeters here. And all I'm left with is 0.88 times 1, which is just 0.88, times 100 cubed, which is a million, divided by 1,000. And I have 1 cubed, which is just 1 cubed. And the unit that I'm left with is kilogram per meters cubed. Now I'm going to simplify this. I'm going to divide, and you can do this on your calculator, but I'm going to divide these and move the decimal to the right by 3, and I'm going to get 880 kilograms per meters cubed. So if you want it, you can definitely try that and make sure you can do the conversions pretty comfortably, and that's what I want you folks to do. I hope this video was helpful in giving you an idea about what is density, what are some of the units that we use for it, and how do we do unit conversions, and how do we calculate density based on different questions. Have a wonderful day.